The single replacement and double replacement are really easy. One second, okay? Single replacement, combustion always reacts with what? Oxygen, okay? So I'm just trying to tell you what's in your class now so you can start studying. After the little bit of reaction prediction, there are stoichiometry problems, 2 of which are limiting reagent. That's why I'm doing another one right now, okay? So I recommend that you write every single bit of this problem down because I've only done 2 big limiting reagent problems, okay? Your problem set 12 has a couple of limiting reagent stuff on there. So I think if I do this now, it'll kind of kill 2 birds with 1 stone because you'll have some more practice. But ask me questions on problem set 12 at the end of class. Because your lab, it depends on how good you are. Some groups finish in like 45 minutes, I had another group finishing around 15 minutes because they were slow. So I want you guys to make sure that you're with me so we can get this lab done. It's basically application of stoichiometry. After that, you guys can see homework. I'll go over that momentarily. So, from your notes Friday, what was your general process for figuring out who your limiting reagent is? Always the first step is what? Huh? Write out the BCE. Step 1, BCE, balanced chemical equation. So let's go ahead and do that now since we can kind of work through step by step. Copper 2 reacts with silver nitrate. I'm ready when you are. See you. I see you too. Sorry. See you. And anybody? Silver has a 1+ charge. Good. Nitrate 1- charge yields. What kind of reaction is this? Single replacement, right? So we're going to go ahead and assume copper can replace silver. Copper is more active than silver, and that is a correct assumption. All right, what's it make? Ag, so pure silver. Ooh, and? Copper what? Copper 2 nitrate. So I am telling you up front what copper's charge is, not so you can use it in the beginning, so you can use it in the end for crisscrossing purposes. Okay, balance. Okay, so we got pure solid silver here, pure solid copper there, and then we've got 2 solutions. Okay, so first step done, balanced chemical equation. Second step, looking at some information, we see blah, 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 2.5 grams of copper, and ooh, look at this lovely information. This is our new stuff, molarity, that some people are still working with. We see that we have information for both reactants. Pretty much whenever you see given quantities for reactant 1 and reactant 2, and it doesn't say who the limiting reagent is, or it doesn't say who the excess reagent is, you have no idea. So you have to figure it out. You have to figure out who the LR is from this process. So that's what I'm trying to point to you. When you have 2 quantities given to you and you're like, I don't know which one to use, you got to figure out who your LR is first. Okay? So step 1, BC. Step 2, use your given information and get to moles. Okay? Because moles is of reactants. Okay? The moles is going to be like a recipe. Okay? So this BCE is not based on grams. It's based on, I need 1 mole of copper to react with 2 moles of silver nitrate to make 1 mole of copper 2 nitrate and 2 moles of silver. Okay, it's not a mass to mass ratio; it's a mole to mole ratio. Or if you wanted to, atom to atom or molecule to molecule, depends on what we're talking about. Okay, so we got to moles. We don't have moles yet, but we will. After we get to moles of reactants, how do you figure out who your LR is? What was the next step? We wrote it down last week. Good. Compare reactants using ratios from your BC, aka your mole ratios. Because, like, for example, if you have 5 moles of something, but you only need 2, is that your excess reagent or your limiting reagent? Excess. You have 5 moles. You only need 2. You got all kinds of excess, right? But what if you had 3 moles of something, but you found out you needed 6 moles of it? That's your limiting, right? Because it's going to run out first. That's basically what you're doing, but mathematically, and writing down have a need, because if you don't, you get messed up with your numbers. After you get down to your comparative nature of this, you'll then figure out who your LR is. And that's the pre-problem. That's how you figure out who your LR is, because after that, you'll continue the problem with your LR have, because that's going to control the entire product amount being produced. Okay, so that's the goal of this, is get the pre-problem done so you can do the real problem. I know, chemistry, I did not make this up, I'm the messenger. Okay, I'm the messenger. All right, so we got our BC done. Let's get to moles. Well, how are you going to get to moles from this? Molar mass. How are you going to get to moles from this? What do you mean? Okay, so this molarity is moles over solution, right? So what I told you last week was big M times V, molarity times volume in liters gets you moles. Okay, so the only thing is we just got to convert that to liters before we multiply. Okay, so that's the trick. Okay, so I'm going to scroll down. I need some space. So here we go. A, 2.5 grams of copper. 1 mole of that weighs 63.55 grams of copper. Okay, what's my next step? Oh no, hold on, I got you. Let me get you the math first. This is 0.0393 moles of copper. And this is how much I have of it. Please label that, because you will not be able to find your word once you get like 15 numbers up here. Alright, that's how much I have of copper. Doing the same thing, but for silver nitrate. What did I just tell you to do to get moles? Molarity times volume. The volume is how many liters? Liters. 0.4000. We're getting real specific here, okay? So 0.4000 liters of solution times, what's the molarity? Give me it in fractional form. You see it up there? What's the molarity? So 0.1 what? Over liters of solution. Good. So this is 0.10 moles of silver nitrate over 1 liter of solution. So I just like to write out all the units so that I can make sure I'm canceling out what's needed. Okay, so liters of solution are canceled, leaving us with moles, which is what we wanted. So this first step is almost done. So 0.4 times 0.1 is 0.04 moles of silver nitrate. Guess what? So much I have of this as well. So I have now determined the amount I have of both reactants. Okay, step 1, step 2 done. What's the next step? Compare them with the mole ratios. Okay, so according to my recipe says I need 2 silvers for every 1 copper. So I need double the amount of silver nitrate, right? Sorry, silver nitrate when I said silver. So if I have 0.0393 moles of copper, I need double that of silver nitrate. I need that much. And so I'm going to write that as a ratio, 2 over 1. This 2 refers to 2 what? Right, because there's a 2 for silver nitrate over 1 mole of copper. And I can write out the whole moles and moles, but sometimes I don't, because I don't want you guys to think that you always have to show every thought that pops into your head, but I'll write this out here for you. This is essentially saying 2-to-1 ratio, 2 moles of silver nitrate for every 1 mole of copper used in the recipe, the BCE. So this is telling me I need double the amount of silver nitrate, like we just discussed from looking at the BCE. So that says I need to react with all that copper, I need 0.0786 moles of silver nitrate. So to react with all that copper, I need that much silver. You with me so far? Okay, look at my silver I have. How much silver do I have compared to how much I need? I'll label it and everything for you. Silver nitrate, sorry, silver nitrate. Just need silver. I need more. I need 0.786. I need 0.0786. I only have 0.04. So what do you already know? Right, it's going to run out first. So I'm already going to go, all right, write this baby up here so I don't forget. This is my LR. This is my excess. Because once I get there, I'm pretty much golden. I can continue with stoichiometry the rest of the way. All right, so now I know who my LR is. Is that the question? What's the limiting reagent? Yep, that's silver nitrate. Okay, pre-problem done. Let's do the real problem. How much, so question, how much silver? What did I tell you much meant? Mass, right. So I'm going to leave some space. I might need this here in just a second. But basically, now that I have my LR, my question is how much mass, how much silver can be made. The reason I have to get my LR is because I have to use my half of my LR to start this problem. That's the whole purpose of finding the LR. Okay, so what am I starting with? Right, so this is my LR. I'm starting with the half of my LR. So I'm starting with 0.040 moles of silver nitrate. Okay, how do I get to silver? Straight up silver. Mole ratio from the BCE, right? So what's the mole ratio between silver and silver nitrate? 2 to 2. And I'm going to scroll back up here just to show you that. So there's 2 silver nitrates and there's 2 silvers produced, so that's a 2 to 2 mole ratio, which I'm going to write right here. 2 moles of silver for every 2 moles of silver nitrate used up in this reaction. All right, so I want to get to mass of silver, which is, figure a table, 107.86 grams of silver for every 1 mole of silver. Okay, so I'm going to make about 4.3 grams of silver. That's a lot of silver. Okay, so now we know how much we can make. Questions on this part so far? Basically, find your LR, use it, get what you want, right? Now, I'm going to skip to part D. I'm not going to do part C just yet. I'm going to skip that. So part D, question. What is the percent yield if 3.64 grams of silver is recovered from the reaction? First off, tell me what percent yield is. Let's write this down Friday or Thursday. Okay, so actual yield over theoretical yield times 100, right? Because it's percent. Yeah? Okay, actual yield. Where would one find that information? Yes, because I cannot expect for you to go to the lab and go, let me figure out how much actually I'm going to make in this experiment, and go back there in the middle of a problem, right? I'm actually going to give you that number because we just don't have time to go get up in the middle of a question and go figure out actually how much you make, okay? So the percent yield if this much silver is recovered. So what is this number representing? Actual yield. Good, okay. Now, what is theoretical yield? What are the circumstances or conditions for theoretical yield? Huh? Okay, what we did on paper, math 4, which we already did, right? Okay, so the reason I'm showing you part D now is because you literally just found the theoretical yield. Okay, I want you to make that connection. Part B is the theoretical yield. We said, from this LR that we have, how much silver could we theoretically make on paper in La La Land when everything is perfect in all ways, right? So this is theoretical yield. Notice your actual yield is smaller, 3.64, and theoretical yield is larger. It's always that way, okay? Normally, we're not perfect chemists. We're not going to get a 100% yield. So your smaller number goes actual, your larger number is theoretical, times 100, move on. So part D, super easy. 3.64 grams of silver. Notice it has to be the same unit, okay? That's just one thing you got to make sure. You're talking about silver, you're talking about grams of silver, you have grams of silver, so we're in good shape. 4.3 grams of silver. The grams of silver obviously will cancel out because of the same unit. That was like 84.7. Yeah. 84.7% yield. Good chemist, bad chemist, okay chemist. Yeah, they're on the rise here. They're almost 90. I'm feeling pretty good about their chemistry. Okay, so percent yield is just a basic percent. You just have to do the legwork to find the theoretical to begin with. All right, last bit. Excess. Who was our excess again? Copper, right? How much did I have of copper? This one right here, right? Have of copper, 0.0393. And to figure out how much is excess actually left over, I told you the really easy subtraction method was, oopsies, take how much you have minus how much you need to get your leftover. So how much did you have of copper? 0.0393 moles. Subtract how much you need. Well, how much do we need, or do we know that? We didn't finish that yet, right? That was a little gap I left up here. I'm going to leave that right here for a second so you can see how much I need, but then I got to scroll back up real fast. So basically, to get my need, is that I need to go back to the very first part, part A, and look at the amount of silver nitrate I had and figure out how much copper I actually needed by doing the mole ratio, so I can figure out how much I need, because I know I'm going to have excess left over. It's just the point of how much. So here, we figured out how much we needed of silver nitrate by doing a 2-to-1 ratio. So what do you think the ratio is going to be here? 1 to 2. It's just a flipped version of that because they're just different, opposite in their reactant ratios. So the ratio, gosh darn it, where's this thing at? It's right here. A 1 to 2 ratio. So for silver nitrate going on the bottom, what was it? 2 moles of silver nitrate for every 1 mole of copper. This is going to tell me how much I need of copper whenever I calculate that, which is 0.02. 0.04 divided by 2. 0.020 moles. Okay, so once I figure out how much I actually need, which is a small amount of the copper, I take that, subtract, to get 0.0193 moles of copper. So, and I could convert that to mass if I wanted to, which I should, but I'm not going to. Whew, very inclusive, right? We've got so much going on with limiting reagent problems, but like I said, you'll have 2 of these. One just deals with percent yield, and one deals with something just like this. So that's why I did this. Keep this safe. Put a star next to it. Say on the free response part of the test, because you will have one where I give you the information given above, like grams and molarity, and you have to do this. Okay, so I just wanted to do one more. Okay, so let's get up, because I think spring break has made us feel sleepier for some reason. So we're going to go to the lab. Let me tell you really quickly what we're doing in the lab. Just listen as you stand up. Your lab is all about the math, okay? Stoichiometry. So you need a calculator. You probably want this problem that you did this morning, okay? And you want a piece of paper. And then listen as before you get going, okay? Give you a second. You're leaving problem set 12 on your desk for me, yes? Leave it so I can see how much you got done. Okay, listen, ready? Eyes up here. Let me see your pretty faces. Okay, so, pre-lab, listen. I'm waiting for people to stop talking. The pre-lab on this is required to be done before you start. The pre-lab's on the back side of the lab. So you'll look through and you'll read a little intro, look through the steps really quickly, turn on the back side of the lab, it says pre-lab. There are 4 questions about the reaction, about what's produced, and then how much of the concentrated 6 molar HCl you need to use. Now this is concentrated acid, please don't get some on your face, eyes, nose, whatever, mucous membranes. So you have to get that before I can approve you to move on, because if you don't, you're going to make an impure form of sodium chloride. We want pure sodium chloride, so we could technically eat it, right? If we're confident in our chemistry skills, we'll see. We'll see your percent yield and percent error, but we're making pure sodium chloride from a reaction, okay? So this is very, very quantitative. You must use, like, look at the meniscus when you're measuring things. Don't overestimate. You want to make sure you're pulling out maybe 3 or 4 decimals so you don't have any rounding error, and then move on. Okay, so just raise your hand when you're done with the pre-lab so I can come see. Pre-lab should take you no more than 10 minutes, okay? Groups of 3, 1 group of 4 at the back lab station. Go. The safety glasses are in the back lab station. Yeah. It's called mole-mass relationships, sorry. Mole-mass relationships. All right, 1 group of 4. That's it. Who's up here? Yes, 4. That's it. 1 group of 4. I think we're good. Yeah. Thanks so much for you. Come on, everybody's here. Let's go.